How did an asteroid impact on Earth kill the dinosaurs, and could such an event happen again in the future? Some 66 million years ago, life on planet Earth was interrupted by a catastrophic event. From what we can piece together today, an asteroid roughly 7.5 miles across, 12 kilometers wide, slammed into the ocean near what is now the Yucatan Peninsula in Mexico. The consequences of this impact would ultimately cause 3 out of every 4 plant and animal species around the globe to perish, ending the dominance of the most famous group of creatures, the dinosaurs. While shooting a planet with a high-speed rock the size of a mountain is clearly going to have some kind of effect on its environment, wiping out a diverse group of animals that had thrived for 165 million years seems a little, well, dramatic. So how exactly did the dinosaurs die? And could an asteroid affect life in the same degree in the future? How do we know an asteroid killed the dinosaurs? Our modern world contains a conspicuous lack of large, toothed, scaly-skinned animals that stomp around the countryside going raw, coo, and chirp, and according to the fossil record, dinosaurs once filled a variety of ecological niches all around the world. The moment in time this all changed is reflected by the contents of the distinct layer of sedimentary rock called the Cretaceous-Paleogene KPG boundary for short. A site at El Kef in Tunisia is used to conveniently represent the standard for this vast sheet, though in reality the sheet of compacted dust stretches around the planet at a thickness of around 2 to 3 centimeters, that's about an inch thick. Below this rock, lots of dinosaurs. Above it, the closest thing to dinosaurs we can find are the smallest feathered varieties we call birds. In spite of being so thin, a few centimeters of sedimentary rock can still pack in tens of thousands of years of material. For decades, paleontologists presumed the loss of dinosaur species was relatively gradual. In the 1970s, the American geologist Walter Alvarez was busy studying the chaotic assortment of rock layers in the Italian mountains, layers which included the KPG boundary. To determine the actual time it had taken for the layer to form, he turned to his father, the physicist and Nobel laureate Luis Alvarez, who suggested measuring the amount of decay in the isotope beryllium-10 as a timer. And it would have been a nice idea if not for the fact that all of the beryllium would have long since decayed, leaving nothing worldwide to measure, so another element, iridium, was proposed as a substitute. As in the case with many of the planet's heavier metals, much of Earth's iridium would have sunk towards its core over its history. Any found close to the surface most likely arrived with the light haze of dust that settles onto our planet each day from interplanetary space. Alvarez and his father expected maybe 1 out of every 10 billion particles would be iridium, and what they found was a concentration 30 times greater. More shocking still, the element was found in concentration levels within this same layer all over the planet. This burst of iridium implied more than the typical gentle dusting of cosmic grit. Supernovas could be ruled out, since there was no trace of the isotope plutonium-244 to be found alongside the iridium spike, which left one sudden dose of space rock. The 1980s was an exciting time for geologists, chemists, and paleontologists keen to piece together the scenario around the asteroid impact hypothesis. And shortly after Alvarez and his father published their hypotheses, their theory, an oil company identified traces of a 180-kilometer wide crater, that's a 110-mile crater, beneath the Yucatan, though it would not be until the 1990s that the Chicxulub Chicxulub crater would be confirmed as the site of the impact that left the iridium found in the KPG boundary rock. And here is the location of it, as you can see right there, in the Gulf of Mexico. Now, today there's little debate over the fact that a large asteroid hit our planet around 66 million years ago, and the timing of this impact coincided with the monumental extinction level event. What is still a matter of discussion is precisely how a moderately sized meteorite could have caused such a change, a carnage. How did an asteroid impact cause the extinction of so many species? Asteroids are obviously bad news for life on Earth. If you happen to be standing close to the impact site, the blast of the shock wave of the impact will quickly turn you to meat sticks into a charred blob, and no mystery there. Further abroad, the pall of dust and smoke in the atmosphere would generate some serious changes in the global climate, altering temperatures and food chains in ways that would quickly see the demise of many species. There's plenty of evidence that Earth was rocked by the gut punch of the KPG impact. Tsunamis, mega ripples point to the sheer power of the explosion. Chemical signatures of the global pall of sunlight blocking particulates back up the likelihood of the planetary winter. And there are even signs of the drastic altering of ocean chemistry that would explain the huge loss of marine life. But there are changes, and as massive as they are, enough to explain the scale of devastation. Sure, it was a big chunk of rock that fell, but life has proven to be surprisingly resilient in the face of large changes. There's some argument that dinosaurs, especially the large ones, were especially prone to large-scale environmental changes and possibly already on their way out. The asteroid impact just tipped them over the edge, and it's a hypothesis that continues to draw heavy debate, with evidence proving difficult to interpret one way or another. Pulse of eruptions from a field of volcanoes, in which is today India, might or might not have added to this as well. No good, terrible day in dinosaur history, throwing toxic material into the atmosphere. While we can be confident geological activity was intense during this period, we're still not sure if it was enough to really impact global the ecology. And one hypothesis that has gained ground in recent years proposes it was less a matter of size and more a precise placement of an impact such as this that truly shakes up the planet's atmosphere. Even moderately sized chunks of rock from space can kick off long periods of serious cooling if they strike geology containing the right kind of mineral. And throw in the fact the meteorite could have come in at a crucial angle, we might have good reason to imagine the same 12-kilometer wide asteroid might have been less destructive had it hit a few seconds later at a slightly different spot, and at a slightly different degree, which would make it less a bad day for dinosaurs and more a matter of terrible timing of a horrible few seconds. Now, could this type of horrible few seconds happen again in the future? Knowing how life is so easily threatened by the effects of a massive asteroid strike, astronomers are keeping their eyes peeled for large rocks that just might cross our orbit sometime in the future. Near-Earth asteroid monitoring programs tasked with giving us heads up on potentially devastating impacts suggest that there's nothing to worry about in the near future, barring rare instances of being blindsided by a rock hidden by the sun's glare, or an asteroid being nudged by gravity in hard-to-predict ways. It seems we've got plenty of time to come up with a plan how to protect our Earth. Still, given enough time, we might expect Earth to experience a similar impact again. If we can't use technology to avoid being struck, we'd need to brace for some kind of ecological consequences. If the conversation of the KPG extinction has taught us anything, it's that there are plenty of variables that could determine the extent of damage caused by an asteroid strike. A smaller impact in the wrong place could prove catastrophic. For instance, while a glancing blow in a less troublesome corner of the globe from a bigger boulder might be less cause for concern. Either way, an ecosystem already weakened by the brink of collapse almost certainly would not fare well from a sizable asteroid strike. If we don't want to go the way of the dinosaurs in the future, we could do worse than ensuring our planet has all it needs to quickly bounce back from a cosmic apocalypse. And this is on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.